With the current generation of premium lenses, ophthalmology has reached the point where cataract surgery has become refractive surgery. The aim is to achieve as much good uncorrected distance vision as possible. Especially with the advent of multifocal toric IOLs, the aim is uncorrected vision for distance as well as near. So any error in placement of these premium lenses is not acceptable at all. Today we are implanting toric IOLs based on surface markings and calculating the axis of placement based on those surface marks. It is important to ensure that the limbus is dry before making these marks. If the surface is wet, the marks get blotched and cover a span of approximately 5 degrees, making it difficult to identify the proper axis. The markers so far available have 5 or 10 degree steps. And we all know that a toric IOL misplacement of 10 degrees leads to a loss of 30% toricity. This prototype device is based on the principles of surgical keratoscope. It attempts to eliminate the need for preoperative markings and all the associated hassles of faint marks, blotched marks and vanished markings. This new device aims in implanting the premium lenses in 1 degree steps in an absolutely no-touch technique. This device has 3 rings fitted one on top of another, capable of rotating independently on a hollow cylinder. It comprises of a holding ring that bears the weight of the device and is secured in place with the help of C-clamp such that it does not fall off inadvertently. The lower ring has 2 wings about 4 inches in length, which holds row of 6 LED lights on each side. This ring has a pointer over there. The middle ring has a graduated scale 0 degree to 180 degree and again back to 0 degree with 1 degree steps. The upper ring holds a medical grade line laser light with an output power of less than 0.5 milliwatts. Now you see the whole device is ready. The device is fitted onto the adapter ring. The objective of the microscope lies within the hollow cylinder through which the reflections of the LED lights falling on the cornea can be visualized. The power sources are now connected. The accuracy and calibration of the instrument was tested previously by fitting it onto the chuck of a vertical drilling machine. The center was marked on a piece of paper beforehand. A 11 mm diameter circle was drawn on it, resembling the limbus, with 2 lines passing through its center, the horizontal and the vertical axis. Line laser light was projected on the piece of paper and rotated to see whether the lights are falling on the 4 lines. The line laser was once more calibrated in the operating room prior to surgery. The procedure comprises of 2 steps. The first step is the photography of anterior segment and identify a small limbal landmark, usually a blood vessel or a pigmentation mark, preferably away from the clear corneal entry. The second step is to superimpose the toric IOL calculation sheet printed on a transparency onto the anterior segment photograph. Then the axis of placement of the toric IOL is calculated from the specific landmark on the limbus with the help of a protractor. In this case, it is 65 degrees. The function of this line laser light is to fall on the specific landmark on the limbus. The 0 degree mark on the graduated ring is aligned at this point. The next step is orienting the LED lights on the bottom ring to the desired axis from the 0 degree mark, which was pre-calculated. This is the desired axis of placement of the toric IOL. The angle between the projected line laser light and the reflections of LED lights from the corneal surface, as it is in this case, is 65 degrees. Let's now move on to the surgery. Now you can see the cataract has been removed, awaiting lens implantation. The line laser light is falling on the landmark and the reflections from the LED lights are 65 degrees apart. The lens is then injected. And the marks on the toric IOL aligned with the reflections from the LED lights. This ensures accurate placement without the need for preoperative surface markings. However, the device is still in its infancy and needs further refinement for mass application. Thank you very much for your kind attention.